We have sum and we have difference formulas, and there's so we did these ones kind of. We kind of looked at these ones, the Pythagorean theorem identities, right before we left. We're doing sum and difference and double angle, so all the way to here today. Now, these look a lot more challenging than they are. The hardest part about these is just spotting them, knowing that that's what you need to use. It's going to be the hardest thing, okay? And then for the next 2 lessons, we're going to use these formulas to be able to do the next 2 lessons, because we do proofs where we sub in these formulas, and then we do solving where we need to sub in these formulas. The people who are good at trig 2 are the people who know what formulas are on this formula sheet. Now people will say to me, well, it's great, they're there, I don't have to memorize them. True, but if you don't know what's on there, you won't spot to fill it in for that. So the people who are really good at trig 2, who do very, very well on the unit test, know what formulas are on here and could almost rewrite them without having the formula sheet. Because you have to be able to know, hey, 2 sine x cos x, oh, right, that's on here somewhere. Where is it? Oh, it's here. I can put it in for this, or I can put this in for this. So the people who do well on this trig test, and I promise you, that's what I've noticed over 11 years, is the ones who know what's on here. Not just have to look and search and try and find something on there. The moment you're searching and finding, I know you're not going to do well on this test. Sorry, but that's just what happens. So you need to know what's on there. How do you get better at knowing what's on there? Practicing all the questions I give you. Okay? So previous to this, I've asked you to give me exact values of something. So I've said, find the exact value of sine 30. And then you went to your unit circle and you pulled an exact value off, because exact value is not decimal, right? So up till now, if ever it said exact value, that meant somehow you're probably pulling off the unit circle. Okay? So if I said tan of something, oh, that was a terrible kit. Oh, that was even worse. Oh. If I gave you tan of 30 or cotan of 30 or cosecant of 50 or secant of 270, or I gave you 540 or something. If I gave you one, it was a coterminal angle that probably landed on the unit circle, correct? What we're going to do today is I'm going to ask you for an exact value. The instant it says exact value, that's a huge hint it's going to have to come off the unit circle somehow. The catch is, though, that they were just like 30s and 45s or 225 or whatever, and you could get a reference angle that was nice. That was either a 30, 45, 60, or 90, right? But how would you solve for the exact value? Exact value screams probably off the unit circle, because how else are you going to get an exact value? If you're plugging it into your calculator, you're getting a decimal. The moment you get a decimal, it's not an exact value. Okay? How in the heck can we pull 75? Is 75 on the unit circle? Yes. There's all the degrees are on the unit circle, right? I told you in between each of those lovely exact values that we have up there, there's little tiny, tiny points in between every single one that connects and makes the whole unit circle, right? People will fight me and be like, no, there's only 45. There is a 57 angle on there. There is a 181 angle on there, right? We just don't have the exact values for it. Okay? 75, though, is there any way that I could turn 75 into some sort of angles that are on that unit circle? What angles do we have? We have 0, 30, 45, 60, 90, 120, 150, 135. Are there any angles that add up to 75? 35 and 40. Are those on the unit circle? Yeah, 30 and 45. Correct. 35 and 40 is not. 30 and 45 are, though. Correct? Sum. We can do addition. Hey, there's addition formulas. Woohoo, we can do this, okay? So the first thing you have to do when you spot exact values is say to yourself, can I find 2 things on the unit circle that add to it, 2 things on the unit circle that subtract to it? You could do that as well. We're also going to do, maybe there's an angle on there that if I do double it, it works out to this. That's where the double angle identity comes in. So you have to be able to spot the word exact value and think, hey, what could I do? Also, after a while, you're going to be like, 75. Why is 75 so much in my head? So think about 75 is a good one. 105 they use because that's 60 and 45 added. And they use 15. Why would they use 15? So you could do 60 minus 45, or you could do 45 minus 30. What if they do, yeah, they do those ones. They do, yeah. Any ones that add up to or subtract from it. Sometimes they do bigger ones too. All right, so sine 75, let's look at it. How could we do it? Well, you told me, well, it's sine, so that's great. So we're gonna keep it as sine. And you told me 30 and 45. 30 degrees plus 45 degrees. Could I go 45 plus 30? Yeah, addition doesn't matter, right? But if it was subtraction, it would matter. If it was a positive 15, you'd have to go 45 minus 30. If it was a negative 15, you'd have to go 30 minus 45. So just like subtraction, subtraction order always matters, but addition, you could do them in either way. Now, the formula for sine addition is this one. It's on your formula sheet, so you don't actually have to have it memorized. This is in the A position, this is in the B position. So this is technically A, this is technically B. We agree? So now you're just going to fill it into the formula. The formula is sine of A. So sine A is 30, times cos of B, cos of 45, plus cos of A. So A is 30. Sine of B, so sine 45. So usually to this point, I can get most people to this point. Everyone's good to here. Want to know where the common error comes? No, we don't want to plug in our calculator. It says what?
Exact value.
Right. What's sine of 30? 1/2. Do you know how many people write just 1/2? Very few. Do you know how many people write sine of 1/2 and then turn it into a decimal by punching into their calculator? The error in this one is that you guys don't drop the sine, cos, cosine on the next step. You're like, but of course I would. No, you don't. Trust me. Like, most people do not. In the next step, they'll write sine of 1/2. Do not do that. If you're someone who's like, yeah, that'd probably be me, star it. Be like, do not do that. This is the common error that happens all the time to most people. Sine of 30 is what? 1/2. You would write it as sine 30 equals 1/2, correct? So that means I could take the entire sine 30, throw it out, and replace it with 1/2. But everyone replaces it with sine of 1/2. Then they type in their calculator and give me a decimal at the end. So they'll have sine of 1/2, and then cos of root 2 over 2, and they give me a decimal. And they're like, I don't know how to turn this into exact values. You're making it way harder. That's what you're doing. So sine of 30 is actually 1/2. So I take sine of 30, I throw it behind my shoulder, and I replace it with 1/2. Then cos of 45. What's cos of 45? 2 over 2. Plus, what's cos of 30? Root 3 over 2. And what's sine of 45? Root 2 over 2. Do you see how all the sines, coses are gone? They're gone, so Alfonso. We do not need them. Trust me, you're like, I would never do that. Yeah, you would. Like most people do. It makes my heart cry. If hearts could cry, it cries. This is actually a really easy question once you realize what it is, because it gets you even common denominators. You don't even have to make common denominators. Root 2 over 4. Do you know how many people write root 2 over 2? A lot. 1 times root 2 is root 2. Root 2 times, or 2 times 2 is 4. I even catch myself oopsieing and writing 2 just by accident. And then what do you do here? Root 3 times root 2. What do you do when you multiply roots? You do not punch them in your calculator, which some people tell me is decimal, blah, blah, blah. That's not good. Remember with square roots, when you multiply them, what's in the front, you multiply together. What's under the radical, you multiply together. So what's in the front of both of them? A 1. So that doesn't change. And then it's root what? 6. So we're just going to get square root 6 over 4. What's great about these, you can't put them together. Some people try and make this, the biggest complication of this I find is people trying to make it prettier. It's not pretty. It's going to be root 2 plus root 6 over 4. That's it. That's as pretty as it gets. What's great about these questions? Go sine 75 in your calculator. What do we have to make sure we're doing? We're pressing that sine button. So the moment we go to press that sine button, we have to think what? Degree or radian, exactly. And in this case, it has to be degree. So press sine 75 into your calculator. Okay, you have an answer. It's a decimal. Lots of people give me that answer. They're like, there we go. There you go, Lepp. Here's the answer. I'm like, I didn't ask just that, like, seriously, you think like a 3-mark question is going to be sine 75 in your calculator? No, it's not. Okay, so that's bad. But it's good to check. Now type your answer in. Your answer is just the exact value of that, is it not? So go √2 plus √6, enter, divided by 4. Or you have to put the top in brackets if you're going to put it all in. Do they match? You move on. You were a happy person. You know you got that written response correct. They do not match? Oh, go back. Try again. Okay? So you can check these all the time. That's what I have here. Always check your answer in your calculator for these. You can always check them. Because you can find sine 75 in your calculator, right? You're just giving me the exact value. You're just giving me the non-decimal version. That's it. So can you not compare them as decimals? Absolutely. But if you just give me the decimal answer, you're not going to get any marks because that's not what I asked for. However, what if it was a multiple choice question on the diploma? Did you not turn their answers into decimals and match them and move on? Absolutely. Chance of them giving it to you as a multiple choice, pretty slim because you can do that. But you could, right? Okay. What's great about these? Well, sine pi over 12. What's pi over 12 in degree form? 15 degrees. Do I have to keep this in radians to figure it out? Could I find sine of 15 and get the same answer? Yeah. You don't have to keep this in radians. Not like you even have to turn it into radians at the end. Your answer is just an exact value answer. It's just a number. It's not like a radian measure or something, right? So we can just find sine of 15. Okay. What is sine 15? What could I do? There's 2 options. Yeah.
Sine 45 minus sine 30.
Sine 45 minus 30. Or we could do 60 minus 45, right? Still 15.
Could you do negative sine 45 plus
Minus negative 60, technically. If minus minus is a plus, then you get 15. But why?
Yeah.
Why? But you could, yes. Okay. So sine of 15 is the same as sine of which one did you want to pick? I don't care. Okay, so we're going to have to go 45 minus 30. Right? You have to do this one in a particular order. So then we're going to fill it into the minus formula. In trig, this whole unit, actually till the very end of the year, your little formula sheet should be your best friend. If you've lost it, ask me for another one, okay? And it should be your best friend and it should be beside you. That's okay. Anyone else?
Thank you. Oh, yeah, I'll be never given to us.
You're welcome. So 45 minus 30, we're going to use the subtraction formula, which is this one. So this is our A, this is our B. So it's going to be sine A cos B minus cos A sine B. And this is our A and our B. So it's going to be sine A, which is 45. And if you put these in brackets, I find that people are less, there's a less of a chance people leave the sines and coses because they actually replace the whole bracket. So sine 45, then cos of B, cos 30. We're going to do these if you are actually using the notes, but I'm going to erase. Minus cos 45 sine 30, I think. Yeah. What's our next step right away to do? Yeah, so go sine 45 is √2 over 2, right? Take it, huck it out, replace it. Cos of 30 is root 3 over 2. Cos of 45, root 2 over 2. Sine of 30 is a half. So I'm going to get root and root would be root 6, root 2 and root 3 over 4 minus root 2 over 4. So it equals root 6 minus root 2 over 4. Now I can compare that to the answer of sine of pi over 12 in radian mode if I want, or sine of 15. I would always compare it to the typed version, not the you found 15 version, because what if you made a mistake and 15 was not actually the degree? So I would go sine of pi over 12 in my calculator, but because I'm putting in pi over 12, I'm going to make sure my calculator's in radians. That's you. When it says exact values, we think unit circle. Then we look at our unit circle, and it's 165 on the unit circle. No. Is there some way I can get 165 by using something on that unit circle? 135 and 30? Absolutely. Okay, let's do that. So we're going to go tan of 135 plus 30. A little bit of fractiony. So the addition formula for tan is tan A plus tan B all over 1 minus tan A tan B. And this is our A, and this is our B. So we're going to go tan of A, which is 135. Tan and cotan are your harder ones, right? Because they're the ones where they're not directly pulled off your unit circle, you have to find them. So tan 135 plus tan 30 all over 1 minus tan 135, 130, and 30. Oops, yeah. So what I would do off to the side before I even fill into any of this is I would get those answers to tan 135 and tan 30 in rationalized form. If you're trying to like rationalize and get common denominators all in an ugly looking fraction, there's a chance you're probably going to make a mistake. Okay, so off to the side, I'm going to find tan of 30 and tan 135 off my formula sheet. And tan is sine divided by cos, right? So off of my unit circle. I don't know why I just said formula sheet. Okay, so tan 135 is sine divided by cos. So I go to 135, and sine is root 2 over 2, and cos is negative root 2 over 2. So it's root 2 over 2 divided by negative root 2 over 2. Whoa, good. It's back. I was concerned. It was working for a while, but it's back. Don't worry. It needed that break just to work for about 15 minutes. It's back to not working again. So we're going to get root 2 over 2 times negative 2 over root 2. What happens? You get negative 1. Because you get negative 2 root 2 divided by 2 root 2, which is just negative 1, right?
Yes.
So now for every single one of these in the formula, that's going to become negative 1. That's going to become negative 1, right? And this one's multiplying, so I'm going to put it in brackets. This looks like 130, but it's actually just 30. Then I'm going to do tan of 30. Tan 30 is y divided by x, or sine divided by cos. So it's going to be a half divided by root 3 over 2, which is a half times 2 over root 3, The 2's cancel, I'm left with 1 over root 3. But remember, what do I want to do before I put it in? Rationalize it. So what's 1 over root 3 rationalized? Root 3 over 3. Because you'd multiply by root 3, and you get root 3 over 3. So I'm going to go in and so now I have negative 1 plus root 3 over 3 over 1 minus, and then negative 1 times root 3 over 3 is just negative root 3 over 3, and it's going to be minus a minus, so what's it actually going to be? Positive. Because it's going to be negative this, right, times negative 1, so it's actually going to be positive root 3 over 3. Now this is a great answer. It's not going to be there. They're going to get common denominators and put the top and the bottom together, and then they're going to divide by the 2 fractions. So we're not done. So I'm going to turn this negative 1 into negative 3 over 3. I'm going to turn this positive 1 into 3 over 3 so that I have common denominators. So I turn the negative 1 into negative 3 over 3. I turn the positive 1 into 3 over 3 because I need denominators of 3 in order to put them together, because you can't add or subtract fractions unless they have common denominators. So we're going to get negative 3 plus root 3 over 3 divided by, and I'm going to write it out sideways. And I'm going to write it out sideways because I have a fraction over a fraction. Yeah. No, these are multiplied together. Yep, these are multiplied together. You have to do multiplication first. So you're going to have to multiply those together first, and then 1 minus that. Yeah. If there was a plus sign in between these two, you could do that, but not because it's multiplication. So then 3 plus root 3 all over 3. And then we're going to flip and multiply. So negative 3 plus root 3 over 3 times 3 over 3 plus root 3. The 3's cancel, and I'm left with negative 3 plus root 3 over 3 plus root 3. That's also a nice answer. They rationalize the denominator. So what do you have to do? You have to times the top and the bottom by the conjugate of the denominator. So 3 minus.
Why is this so much harder than the sine and cos?
Because tan is a fraction. Yeah, I don't disagree. Okay.
Like, there's 400 steps.
400 might be an exaggeration. 20 might be more close to what it actually is. You've got time for that. Okay. Negative 3 times 3 is negative 9. And then negative 3 times negative root 3 is positive 3 root 3. 3 times root 3 is positive 3 root 3. And then root 3 times negative root 3 is just 3, negative 3. Over 3 times 3, which is 9. And then root 3 times negative 3 is negative 3 root 3, positive 3 root 3. So the middle terms cancel, as they should. That's why you multiply by the conjugate. And then root 3 times negative root 3 is negative 3. And so on the top, I get negative 12 plus 6 root 3 over 6, which is nice. But I can take a 6 out of all of them. So your answer is actually negative 2 plus root 3. But look at how pretty that answer is.
Yeah. It's really worth it.
So punch into your calculator, tan 165. Punch into your calculator that answer, and if they don't match, we all cry. Okay. Do we flip angles? No. We flip answers. So we could get the answer to cos of this, and then what do we just do to our answer? Flip it. That's it. We cannot flip angles. Do not flip angles. When you go to flip an angle, you slap your hand and you say, no flipping angles. We do not flip angles. Just no. That's what you do. You say, we can flip the answer, Lepp. We cannot flip the angle. That's what you say to yourself. You say, self, no. No self. Stop the madness. That's what you say. Because half of you were telling me to flip 12 over 5 pi. No. Bad. Okay? Bad. You flip the answer. Yeah. Star that, or on your forehead. I don't really care. We can't read your forehead. On your, just get it embedded. Yeah. All right. No. This one isn't as bad. You'll be okay.
Well, I gotta hold on
because it's just cos of 5 pi over 12. So what is 5 pi over 12 in degrees? Because just go 5 times 180 divided by 12. Okay. So it's cos of 75, which people are like, not the 70. It's only really bad when it's tan, okay? If it's cos or sine, life is okay. If it's tan, sorry, it sucks. It's just how it's going to be. Live with it. Okay, but when you see cos and sine now, you should be super happy. Or even secant or cosecant, who cares? Do cos or sine and just flip the answer. That's it at the end. So whenever you see a secant of an angle or a cosecant of an angle, don't freak out. Find it for cos or sine and then just flip it. That's it. It's not stressful. Don't make it that way. Do not flip the angle. Do not flip the angle. Do not flip the angle. Okay, so we're going to do cos of 75. Cos of 75 is just cos 30 plus 45. Or 45 plus 30. It does not matter. So it's going to be cos 30 cos 45 minus sine 30 sine 45. So just pulling that off the formula sheet, that's all I did. Cos 30, cos 45, sine 30, sine 45. Coses are cos, cos, sine, sine. Opposite sign in the middle. Okay. So cos of 30 is root 3 over 2. Cos of 45 is root 2 over 2. Remember, you're completely replacing them. You're not keeping the coses and the sines. Stop. Don't do it. If you're someone who's going to do that, leave yourself definitely a star. Okay? Minus sine of 30 is a half. Sine of 45 is root 2 over 2. So I'm going to get root 6 over 4 minus root 2 over 2 or over 4. See, I just about did it. I do that the odd time. And you're going to get root 6 minus root 2 over 4. Now, don't stop there. Why? You have to flip it, which means you're actually going to have to multiply by the conjugate. I know, Kate, you may be freaking out a little bit right now, but just remember the tan. Just go back to the tan question before. This is really not that bad. That's why I put them in the order of this one's like makes you feel like your heart's singing. This one makes you feel like you're kind of dying a little inside. Then you get to this one and you're ready to complain, and then I'm like, just remember the last one. You're like, okay, ain't that bad. All right? Okay. So if I went in order of this to this to this, you'd be like, and by death by the end. But now you're like, sweet, it ain't that bad.
You should have done 10-165 in the beginning.
No, because then no one has a clue, and they just cry, and then they just shut down and don't listen to me for the rest of the lesson.
Okay, well that's actually,
all right. So you go 4 root 6 minus root 2 for the secant, right? Because since we need secant, we don't need cos, we need secant. And then we're just going to mash or multiply by the rational conjugate, radical, not rational. So root 6 plus root 2. So we're going to get 4 root 6 plus 4 root 2, because you're going to distribute it. And then because the bottom's the conjugate, you just go the first ones and the last ones because the middle ones should cancel. Root 6 times root 6 is 6. Negative root 2 times root 2 is negative 2. So you get 4 root 6 plus 4 root 2 over 4. And the 4's cancel, so you just get root 6 plus root 2 in teeny tiny writing. Because the 4's all cancel. Super teeny tiny. We're going to do double angle and proofs, starting proofs tomorrow. But often I see on the diploma the other way. They'll give you an answer like, they'll give you a question like this and they'll ask you for the answer. What you have to do here is you have to spot that that's just a sum and difference formula. It looks exactly like the sum and difference. These are actually easier if you spot them, but people don't spot them. Thank you. So it's root 6 plus root 2. You can't see that. It's really written quite well. I don't see your issue. Like super, super awesome. Yeah, it's just root 6 plus root 2 in really scrambly, ugly writing. Okay. So we have sine cos, sine cos. What's the formula that has sine cos, sine cos? And what's the screaming, hey, notice me, is the fact that there's 2 10s, there's 2 hundreds. If your angles are the same on both sides, that's like, hey, where did I see that? Oh, right, sum and difference, yeah. So this is actually the same formula as sine subtraction, right? So this is just sine A cos B minus sine B cos A, correct? Which is just the sine subtraction formula. They just have these flipped. You just have to spot that. So it's going to be sine A minus B, right? So it's sine A, which is 100, minus B, which is 10. Woohoo, sine of 90. I like sine 90. What is sine 90? See, happiness right there. Isn't that happiness?
See, like, that's what I'm talking about.
If you spot it, it's the spotting these. But you should spot them. It's sine, cos, sine, like where did you see that? Where have you seen that? And then people are like, but it's not the same. These are not written like this. Please, they're the same. It's the same thing. Just imagine it.
Notice that.
Seriously, you would have, because then you would have went to your formula sheet and you would have been like, it's so close, but it's not the same. So many people do that. It is actually the same. Okay?
Just kind of imagine brackets.
Yeah, totally. Uh-huh. So then this is an addition. Sine, cos, sine, cos. So this is A, B,
Whoa.
B, A. Oh no, it's different again. Oh, actually it's the same. They're just flipped, right? So we're just going to do sine A plus B. So it's going to be sine A, which is pi over 6, which is 30. B, which is 60. Oh, look at this. The joys. The joys. Where have I seen that before? There. 1,